an isosceles triangle has two legs and it has a base? Well, in an isosceles triangle, the legs are congruent. They can be in a right triangle. You can have an isosceles right triangle, but not always. But each of these is called a leg. They may be the same, they may not. Do you know the name of the third side? The big old name, hypotenuse? Yeah, you've heard that one. And I'm sure that has Greek background. And the hypotenuse will always be your longest side, which is kind of nice to know. And then the Pythagorean Theorem, I like to say, leg squared plus leg squared equals hypotenuse squared. And I'm just going to abbreviate that like that. And if you want to put letters to them, A and B would be the legs. If you want to do it like that, I'll put arrows. Whatever. I'll just do it like that. And then C is the hypotenuse. I'll do it like that. So if you do say A squared plus B squared equals C squared, remember that the A and B are the legs. Number 1. We'll use this one. And we're going to put X here. And I think they put question marks. You know, I always like to use X's. And 8 and 10. That's the algebra teacher in me. What are the two legs? Which ones? Which numbers, variables? 8 and 10. So you got to know that. And it doesn't matter which way it's turned, so you got to watch. The hypotenuse is always the longest one, and it's across from the right angle. You can find that right angle, go straight across from it. So 8 squared plus 10 squared, or 10 squared plus 8 squared, it's commutative, equals x squared. So I got 64 plus 100 equals x squared. Be careful with your algebra. I see a lot of people do this, and then they're real sloppy with it. They'll put x, and then they don't put x squared. And we need to talk a little bit about undoing the idea of squaring. You know, if you want to get rid of addition, you subtract. If you want to get rid of multiplication, you divide. If you want to get rid of squaring, you have to take square root. We'll do that in just a second. So I got 164 equals x squared. If you like your x's on the left, we'll do that symmetric property and turn it around. Well, if x squared is 164, then I need to find what x is. And what you have to do is take the square root of this side. Well, we know if you do anything to the left side, then you have to do it to the right. Now, remember, let me turn back real quick. Remember, the square root of 4 squared is 4. The square root of 10 squared is 10. So the square root of x squared is x. Look, I got what I wanted. Uh-oh. Now, 164 is not a perfect square, is it? Is it in your list? No. So let's go over here and you're going to get some not so pretty factor trees on these. And usually they're not. Some of them are perfect squares, but not all the time. We definitely know 2 will go into it, which gives me, what, 82? And 2 will go again, and it's 41. And 41, I mean, if you go through your list, you pretty much know 41 fits into factor trees, and it's it. 1 times 41. It's prime, you're through with it. So you've got, I guess we better put the whole step in there. It's going to have 2 squared times 41. So, now this is exact, and we're going to leave it 2 squared of 41. Number 2. This time we're going to put the square root of 13 right here, and we're going to put one of our legs as x, and that's probably by somewhat scale, it's going to be this one, and this one's going to be 2 squared of 3. Okay, now what are the legs in this one? The 2 squared of 3 and the x. So I've got x squared plus, now when you write 2 squared of 3 squared, you're squaring the whole thing, so you got to put it in parentheses. You have to. If you don't, you're only squaring the square root of 3. Equals the square root of 13. And I'm going to go ahead and put it in parentheses, even though it has a 1 in front of it. It's just a good idea when you have parentheses, a radical in this, to go ahead and put parentheses around it. Okay, now we did x squared plus, now we did this in our classwork, I think, in lesson 20, if you worked on 20. Let's go over here and do a little scratch work. Actually, we can go down here. Let's go down here and do 2 squared of 3 squared, which we know is 2 squared of 3 times 2 squared of 3. We had some just like that in lesson 20. Okay, we said multiply the rational, that's the outside, which is 4. Multiply the irrational, that's the square root of 3 times square root of 3, which is square root of 9, or 3 squared, which is 4 times perfect square 9, and we get exactly 12. It's pretty nice. So now be careful. That's not 12 squared. That's 2. See, the 2 squared root of 3 times the 2 squared root of 3 is the 12. Now, can you do that one in your head? Square root of 13 times square root of 13. If I write it like this, will that help you without having to use your calculator? Square root of 13 squared. Ah, yeah, but you don't need that, do you? Do you? Look. Square root of 10 squared is 10. Square root of 52 squared is 52. What's the? I didn't even have to write 169. See, that's where I want to get fast for that ACT. Square root of 13 squared is 13. If you square a square root, now this one we had to do a little more because we had the 2 to square also. And so we get 13. Wow. Now we need to get rid of the 12. We get rid of addition by subtracting. See, that just comes second nature. And we get x squared equals 1. Now we got to get rid of the squared. And I'm going to really hold your feet to the fire on that one of writing it correctly. Don't drop the squared off. People drop it off, they put it back on. It's important like everything else. So let's do the square root of both sides. And what is the square root of 1? 1. 1 times 1 is 1. Now let's go backwards. Let's go to the top of page 49. Okay, if you have a triangle, is a triangle a right triangle? Now this is actually going backward of the Pythagorean theorem. If short side squared plus the other short side, now they're not necessarily the same, they could be, equals the long side squared, then yes, it is a right triangle. Let's see if this makes sense. Okay, number, where are we, 3? Okay, let's first, and I don't think they're going to give you one that's not, but let's go back to that lesson, I think it was 17, and decide if it's a triangle to start with. Because if it's not even a triangle, then it sure can't be a right triangle. Now, I think everything they give you is going to be a triangle, but I just want to verify those rules. So take the 2 short ones. Is 9 plus 12 bigger than 15? Yes. So it is a triangle. Now, is it a right triangle? Now, be careful because sometimes these are not in order. So let's take the short side, one of these 2 short, 9 squared plus 12 squared. Now, this is the way I do it. I put equals, and sometimes I put a question mark there, or you could put it out here like this. Is this true? You know, I put 9 squared plus 12 squared. Sometimes I put my question mark right there. But I'm actually saying, and I'm okay with you just putting the equals there, but we're actually really wanting to know if that's true or false. 81 plus 144 equals 225. Please do the arithmetic, and don't stop there. Please finish it out, and that's 225 equals 225. So yes, this is a right triangle. So if it says justify your answer, show your work, this is what I want. And I want you to finish it out. Don't just leave it hanging that I got to figure it out for you. Number 4, 6, 10, 12. Now, I didn't do one with a radical, so it makes me think you don't have one. But if you do, you do it just like we did in number 2. So 6 squared plus 10 squared. 6 plus 10 is bigger than 12. So 6 squared plus 10 squared equals 12 squared. Now, at some point, you may just look at it and say, no, it's yes or no. But please finish it so I know what you're thinking. 36 plus 100 equals 144. Now, at that point, I know it's not, but I'm trying to get through for what you have, and they're not equal. You can do that. You can just say, no, it is a triangle, but it's not a right triangle. I hope that makes sense. Okay, that's about the best we've done. We didn't have a quiz today, which always makes it nice. So this is your lesson. I have no idea. Was there one due today? I don't remember what it said up there. There was a check, but it wasn't due, which it was probably 20. Okay, I say this, and y'all are actually doing pretty well. The other class is struggling a little bit that they're turning in the lesson the day it's due, and I've never checked it. And that's dangerous because it's hard on some of these lessons.